The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
I'm Ryan Henkensiefken, Business Development Engineer for Central Concrete. We are a ready-mix concrete producer in the San Francisco Bay Area, so we deliver concrete into San Francisco, down into San Jose, into Oakland. We do about 1.5 million cubic yards a year, so we're one of the kind of larger ready-mix producers. And I am an engineer with them, and I spend a lot of time on the design side of buildings. So I work with both architects and engineers doing educational seminars, working through their specification. Karthik had mentioned that one of the big issues that we see in our industry is the fact that specifications limit the use of fly ash or slag or whatever SEM that it is that you want to use. I spend a lot of my time on the day-to-day working through those issues, doing a lot of education. So some of the roadmap issues that Karthik had mentioned, we as Central Concrete are already doing that, and that's where we've seen a huge benefit from that into the actual placement of a lot of concrete with very low Portland cement. So we started in 2005 starting to look at our carbon footprint and start to look at our operations and how we impact the environment. And before that, we essentially just had cement and fly ash in most of our plants. And if you look at the carbon footprint of our product, when I talk to a lot of designers, they would see a lot of ready-mix trucks going in to our ready-mix plants, a lot of ready-mix trucks leaving, and a lot of material haulers bringing in all of our raw materials, and they would say, well, you guys are essentially in a form a trucking company. You must have a large carbon footprint associated with the transportation. But if you actually look at it, our delivery truck fuel, which is essentially our material coming in, and then we have, there should be diesel combustion is actually what we're spending on our trucks, our ready-mix trucks going out. You add those two together, that's only 6%. Now we have using a lot of slag cement and fly ash, but with that, cement is still a large piece of our carbon footprint. And so we started looking at ways to reduce the amount of cement. So there's, I guess, a kind of couple different ways that you could go about doing that. One is to increase the amount of fly ash and slag that we're using, which is a good way to do it. Another way is to take a look at the specification and realize that everything that we're doing, not everything, a lot of what we're doing in terms of concrete placements are grossly over-designed. And so what I tell all of our project managers is take a look at the specification and see what it is that they're trying to get at, and let's submit that first. It's probably going to get rejected, and at that point, that's when I can go in and have a conversation with the engineer of what it is that they actually need. And a lot of our structures are vastly over-designed for the amount of cement that we're putting in it. So typically what I would see as going into a lot of specifications are these legacy specifications that will have a minimum cement content. And that minimum cement content may be 5 sacks or 6 sacks or 500 pounds, however they phrase it. And a lot of times they're concerned about early strength, set times, things like that with the contractor. And there are ways to get around that and ways to deal with that with the contractor that don't necessarily need to have that in the specification. So we've seen a shift in our specifications in the last 10 years that have gone from minimum cement contents, minimum sack contents, to actually the opposite. There's a large, very large job being done in the South Bay near San Jose that's a several billion-dollar job that the specification for that actually had the opposite. It had maximum cement contents. And they were actually really, really aggressive on the maximum cement content that they wanted. The foundation mix that they wanted was 200-pound maximum cement. Some of the columns and walls were 300 pounds. maximum cement. So we're starting to see a shift in the Bay Area from those kind of legacy type specifications of maximum cement, maximum or minimum cement, minimum sack content, to maximum cement, minimum SEM percentages. So who Central Concrete is, I'll kind of give you a little overview of what we do as a company and the way that we've changed in the last 10 or so years. We like to think of ourselves as the leader in delivering low CO2 concrete. And the way that we do this is essentially replacing a lot of cement with fly ash and slag. Our standard mix that we put out the door every single day is 50% cement. It's 50% cement, 30% slag, 20% fly ash. That's our standard mix. If I had my laptop, I could actually bring up the order snapshot for the day. When I looked this morning, we had about 4,000 yards that we were doing. And I would say about half of that is with this 50% SEM mix. It's very common for us to use it. We've done structural mixes up to 70% cement replacement, and what that's not typical of is where we would see maybe when you start talking about percent replacement is people taking a 6-sack mix and adding in another 2 sacks on top of that and replacing 50% of 800 pounds. All of these mixes that we have are kind of standard compared to straight Portland cement. So it's 500 pounds of Portland cement. For a normal mix design, we'd have 500 pounds of total cementitious. We cut out half of it. We've done mixes up to 70% replacement, and I'll show you a couple of projects that have done that on. It was nice that Karthik had actually talked about the Architecture 2030 Challenge for products. We've pledged to that, and we're on pace at the end of this year to meet the 2015 goal of the 35% reduction. How we're going to get to the 2030 goal, we don't know. That's what some of the sessions on for the second part of this will maybe help with, of how to increase either our percent usage or to under-design, I guess, I shouldn't say under-design, cut back that over-design that we have on some of our projects, because it's not just about cement replacement, it's about just taking the total embodied carbon of the concrete mix design and lowering it. We're the first U.S. concrete company to adopt EPDs, and I'll show you what those are and why they're important to our operation. And as far as we know, I think we're the first ready-mix company in North America to actually have third-party validated EPDs. And those are the environmental product declarations. They're essentially telling us how much carbon we have and other environmental impacts that we have in our concrete. Some more quick facts about Central Concrete. We are in the Bay Area for 60-plus years. We actually acquired Bodie Concrete, which is in San Francisco. Bodie Concrete has over 100 years of experience in the San Francisco market. We have just acquired some new trucks, so we have 229 trucks, and we have 12 Bay Area locations. The reason why I wanted to talk about this is talking about the investment that my company made in our plant operations, because for a lot of ready-mix producers, I would imagine that aren't using a lot of SEMs, the fly ash or slag or silica fume, whatever it may be, there's probably two big reasons for that. One could be that it's just not available in their market, and the second reason being that they have to actually take and put in capital into their plants to be able to handle those materials on a pretty wide basis. So we actually invested a lot of money putting in brand new silos or splitting silos to be able to handle all those different raw materials that we bring in. And that was a big part of the reason why we're able to do what we're able to do at all of our locations, because it's important for our customers, no matter where they have a job. We have a lot of big customers that are doing work in San Francisco, San Jose, and in Oakland, and they want to be able to do everything that they do in all of those locations. So that's probably a reason why we're not seeing as much usage as either raw material supply or the actual investment that it takes for a ready-mix company to be able to do it. So let's talk about some projects that we've done that I think are kind of interesting to talk about. You'll hear a lot more about actual materials and mixed designs. I thought it would be nice to be able to talk about projects and some of the successes that we're seeing. I'll start off with the Packard Foundation. This is the largest net zero energy building in California. They actually are considered net zero energy now because they had that 1-year trial period that they had to go through and double check. Our primary mix design that we had on this for foundations, for walls, for columns was 70% cement replacement. I believe it was only 250 pounds of cement in it. So This is one of those things where we decided to push the envelope a little bit with the owner because they were very interested in what we were doing, and being able to do something where we had a very low cement content mix on an entire project-wide basis was kind of unique for this project. And we've started to deliver this mix to other locations as well. I believe in the part of the foundation elements for the Facebook campus, we're actually delivering this mix design. The San Francisco 49ers Stadium is currently being built by a joint venture between DevCon Construction and Turner Construction. And this is an extremely fast-paced project. I gave a talk last night where I actually talked about the penalties for this project. If they miss a 49ers game because of the delay in schedule, it's a $6 million penalty for them. And if they miss some time on the preseason, they could have up to about a $20 million penalty. There's a huge incentive for them to get done early as well, which luckily it looks like they're on pace to do. But it's an extremely fast-paced project, and we delivered a lot of our 50% cement replacement mixes on this project. We reduced the estimated, because the project isn't done, we're estimating that we'll reduce the carbon footprint of this project just in the concrete structure. And this is, it's actually the structural element or the seismic elements are all steel frame. So there's not a lot of concrete on this project compared to some other projects as a percentage of the total job. But we're still estimating to reduce the amount of carbon on this project by 23 million pounds, which is a considerable reduction. Another project that we're working on in San Francisco is the Trans-Bay Terminal. They're talking about it being like the Grand Central of the West, where we have several different rail lines coming into it, from BART, which is kind of the local rail line, Caltrain, the high-speed rail eventually, if they ever do a high-speed rail that actually makes it up to the Bay Area and doesn't just stop in Fresno. So that will be a huge project that they're working on right now. We're finishing up some of the underground work for it. And it was kind of a unique project in that they had a maximum strength and a minimum strength on some of the foundation elements and the drilled shafts. The reason why they are doing that is they had this secant pile method that they're doing where they're putting in 2 drilled shafts, and then a couple days later they're going in and drilling in between those 2 and pouring another shaft and having this locking shaft system for the foundation. And so they had this maximum strength that they wanted to have at 7 days because they actually wanted to drill in within those first 7 days, but then they had to have a minimum strength because they actually had to have structural integrity of the finished product. And depending on the schedule that they had, we had anywhere from 50 to 75% cement replacement in those mixes. We also poured some concrete on the San Francisco-Oakland Bay Bridge. Very unique structure in terms of its design, its seismic design. 50% replacement on that. So you can see that there's a lot of projects, and I got even more that I'll talk about here, that this is common practice for us now. The California Academy of Science was our first real project where we started to work on this on a kind of a mass scale. This was done in 2005 or 2006, I forget the exact date. And you can kind of see this undulating roof structure, really kind of unique. They needed to have ultra-low shrinkage for it because they didn't want to have cracks in it. But this was our first go at this, and this was 10 years ago, and we were doing 50% cement replacement on this 10 years ago. And so for us, it's Central Concrete. It's kind of been a progression. This was probably not the most friendly mix for the contractor. It probably didn't meet the schedule that they wanted to have 10 years ago. But we made a lot of progress in what we've done recently. And kind of the highlight of that is this building here, the San Francisco Public Utilities Commission building. If you were to drive through San Francisco going to the Golden Gate Bridge and you're on Van Ness Avenue, you would see this building here. It's a really unique structure. It's a crazy design with what Tipping Mar did in terms of their structural design. It's actually a vertically post-tensioned building so that when the earthquake happens, which we know is going to happen, it's just a matter of when, it kind of acts as a spring. So as that building shakes, it kind of will do this thing and be flexible with the earthquake, but then come back to center right away. This is a structure that they need to have running immediately after the earthquake because it essentially is going to help run the city with its utilities. So with this, there's a lot of post-tension concrete in this. Vertical post-tensioning, horizontal post-tensioning, the whole building is post-tensioned. And a lot of the mix designs that we had, like in the foundation elements, were 70% cement replacement. But in the post-tensioning mixes, we actually had 50% cement replacement, and we were able to post-tension within 2 days. And that was getting 4,000 PSI in 2 days with 50% replacement, which this mix on the post-tensioning was a maximum of 350 pounds. That's how they, Tipping Mar specified it to go out to bid, was a maximum cement limit. What we found out, what Karthik was talking about earlier, some of the benefits of doing different types of testing at different ages. So this was actually the specification when we met with Tipping Mar when they were first doing some of the preliminary designs, was to move the specification from 28-day strengths all the way up to 90-day strengths. And we did a lot of work on the maturity testing to ensure that they get the strength that they want when they need it. And I talked about DevCon Construction and the project that they're working on with the 49er Stadium, and I met with one of their superintendents, actually one of their head superintendents, and we were talking about what we can do to help reduce the carbon footprint of their projects, because they do a lot of work in the Bay Area, but at the same time be able to meet their schedule. And we talked about a number of different things, but maturity meters were the big thing that we talked about. And it was funny, he kept on having all these problems with low strengths and getting a bunch of information back from the lab. And I took a look at the results and said that this mix should be killing it for you. It shouldn't be a problem. So what we ended up doing was, well, not even what we ended up doing, what he ended up doing was calling the testing lab and said, my jobs are a one-way ticket. That means that you're going to come up to my job, pick up the cylinder, you're going to bring it back to the lab immediately, and then you're going to do the testing there. The moment that they started doing that, they actually started to hit the maturity meter or the maturity curve on the button every single time. So testing is a big issue when it comes to doing some of these mixes, is that they're probably not as robust as the 100%, 20% fly ash mixes. So being able to properly test them is really important on a lot of these projects. I wanted to finish off kind of just talking about some of the work that we've done with our environmental product declarations, which is essentially measuring the carbon footprint of our product. So what I'm able to do with the system that we have built, that it's tied into our command batch system and our command concrete system. So it takes all the materials that we have and all of our mix designs, and there's a lot of them. I think last year I had somebody in IT download all of our mix designs for me and send them into a spreadsheet because I want to take a look at them. And we had 70,000 mix designs in the Bay Area, and we use probably 5,000 of those on a pretty regular basis. So it's quite cumbersome, a quite involved process to actually try to measure your carbon footprint for the individual product level. But we've built a system to be able to do this with a company called Climate Earth that has done a phenomenal job. So what I'm able to do is log into this system, select my service area. Here I selected San Jose. I can select these mix designs here. These probably mean absolutely nothing to anybody here. They don't even mean a whole lot to people in my company. They mean a lot to me because I can read it and tell you exactly what's in that concrete mixture. So I select that mix design, and what I end up with is some information on how we calculated it using certain product category rules, and if you want to know more about that, I can talk to you about what those actually mean. And that they're this one happens to be third-party validated, externally verified. We have some self-declared ones as well. But what we end up getting is some performance results, and then ultimately our environmental impact with the global warming potential of the CO2 emission essentially right here. This is including all upstream pieces of our supply chain as well. So it's not just what our operation is doing, it's what our suppliers are doing. And the reason why this is important for our operation is you can't change anything if you're not measuring it. So from a total company perspective, we're measuring our company carbon footprint, but we're also looking at our individual project managers. We have, I think, 11 different project managers who do manage the projects in the Bay Area for us, and they're being measured on a yearly basis on how well their projects are doing in a reduction in the amount of CO2 on average for their projects. So there's a constant vigilant focus for us as a company on this, that it's part of they're also judged on how much money they're making for us. So there's an economic piece of how they're being judged, there's a sustainability piece of how they're being judged, and a safety piece really of how they're being judged. So this is a big thing for what our industry, I think, as a ready-mix company, needs to really focus on is proper measurement of what we're doing and the impact of that, and keeping a huge focus on that. So with that, I'll kind of end that. I believe we should have maybe some time for some questions. So if anybody has questions, I'd be happy to take them.
Yeah. Ryan, on just your point about testing, the DevCon job with the supervisor said about getting the specimens to the lab quickly. Because handling was...
Yeah, well, because I think a part of the issue, this is just an issue with testing in general, that if the cylinders aren't handled properly, you'll have some low breaks, and I think that gives a kind of a bad taste in people's mouths for any concrete, but specifically for things that don't have as much Portland cement in it, they're a little bit weaker at earlier ages, so they're a lot more susceptible to damage and transport. So what the point of that I was trying to make with that was just really talking about the importance of handling those cylinders early so that you get proper testing done, so that it's, because there's some misconception on early strength issues that we see out on job sites that aren't really early strength issues, they're really testing issues. And when testing is done properly, as compared to a lot of the maturity testing that we've done, it's not as big of an issue as people, I think, perceive it to be.
Thanks, Ryan.
Anybody has any other questions, let me know.